Okay, so our second linear regression example for today is fast foods are often considered unhealthy because they are high in both fat and calories, but are the two related? So here's data for 7 burgers. We have their fat content and their calorie content here. So it makes sense that if something has more fat, it would have more calories. There's other things that contribute to calories other than fat, though. So let's use this data, see how it looks over in Minitab. So I'll bring this over to Minitab. This was our fat column. This was our calories column. I guess I could have just included the column headers in my copy and paste, then I wouldn't have had to type them again. Okay, so let's run regression on these new numbers. I guess I'll put fat on the x coordinate and calories on the y coordinate. See what we get. Okay, R squared 91%. So that's one of the better numbers we've had. So these are a pretty good fit. There's only 6 dots. Actually, there's 7, I think. Is there 7 here? Yes, so there's actually 7. I can only see 6 on the graph because 2 of the dots are in the exact same spot, actually. So there's 7 dots on here, which is not a very big sample, but they're all pretty close to this line. So we have this one that's close to the line down here, and these 3 that are close, and these 2 that are pretty close also. So they're all pretty close to the line, and our R squared is 91%. So first thing that I had asked for over on the worksheet was what is the R squared number, and then I wanted this formula up here, the regression equation. So in order to find calories or estimate calories, we take 199 plus 11.57 times the fat number. So calories equals 199 plus 11.57 times the fat number. Okay, and that's everything I want for Minitab. So let's flip back to our Word document and answer the rest of our questions. So 91% is our R squared. The formula for our line is 199 plus 11.5 times fat. So if fat goes up by 1 gram, calorie content goes up by 11.57. And that's a positive slope, so it's 11.57 higher. When fat goes up by 1, calories go up by 11.57. This one has something new, interpret the y-intercept. So what does this 199 mean? Well, I guess the y-intercept is when the x-coordinate is 0. So if fat equals 0, calories equal 199. So we are estimating that a fat-free burger will have 199 calories. Okay, so does that make sense? That makes sense. There could be such thing as a fat-free burger, and it would probably still have some calories, especially if it still had sugar in it. It would probably have more than 199 because they would probably add in something like extra sugar to replace the fat so that it still tastes good. But at least it makes sense. In our previous question up here, it would also make sense to have a country that has 0% marijuana use. I mean, there might be such a country, but some of the linear regression we do wouldn't make sense to set the x-coordinate to 0. Like let's say we did a linear regression on people's height and weight. We say taller people probably weigh more, shorter people probably weigh less, and it wouldn't be perfect because people have different body shapes, but generally there's probably a correlation between taller means heavier. But in that context, setting the x-coordinate to 0, setting your height to 0 doesn't make sense. There are no people whose height is equal to 0. So sometimes setting the x-coordinate to 0 doesn't make any sense in the context of the question. in this question, 0 fat in the burger, that's possible. I mean, you'd have to have some way of like getting all the fat out of beef. That can't be easy, but I assume that it could possibly be done. Okay, predict the number of calories with 40 in a burger with 40 grams of fat. So we just have to take this formula up here and plug in 40 in the fat spot. Is that a big number? It's sort of in the middle of most of these, I guess. So what do we get if we take 11.57 times 40, and then we add on the 199? This comes out to 661.8. So that's our prediction. And it should be a pretty good prediction because we had 91% R squared compared to some of the lower R squareds we had in other examples. All right, so those are the two examples I had for today. I do have one last thing that I want to talk about, but we're not actually going to do any computations there. So I have one last short video for today that isn't another Minitab computation. It's more just sort of talking about the value of doing linear regression, when it's useful and when it's not useful. So stop this video and then record that last video.